narrow window that you can actually see and notice that is visible in your environment. So the visible spectrum. So visible light is a wave that we can see. The visible spectrum includes all those colors that you are familiar with that you can see right here, otherwise known as Roy G. Biv, or red, orange, yellow, green, blue, indigo, and violet. So visible light allows you to see those 7 colors. So those 7 colors make up the visible spectrum. That's what we can see in our environment. Each color emitted has a different wavelength. So this is what's kind of tricky and interesting about this. So of those waves that make up visible light, red has the longest wavelength and the lowest energy. So what causes you to actually notice whether or not an object is red is that that object reflects the red wavelength back at you. So that's what you're noticing when you're looking at that object. So for example, if you looked at a red hat, that hat isn't actually red, it's just reflecting back that wavelength at you. So violet has the shortest wavelength, so it's a little bit smaller than blue and indigo. So it's sitting over here, so it's got less space in between it, versus red is the longest wavelength. And if you think about the electromagnetic spectrum, so red is sitting on this end. A nice way that I like to think about when I remember it is infrared is actually coming right before red is, and violet is coming right before ultraviolet is. So visible light, that's making up everything that you can see. So when you get the idea of white light, so for example, over here, white light, the coming out of a light bulb, or again, it coming out of the sunlight. White light is a combination of all these colors together that you just perceive as white. And we'll talk about color a little bit later, but for now I want you to kind of understand that the visible light spectrum is everything that we can see when we're talking about light. Some examples of visible light, just pop them all up. So where does it come from? The sun, light bulbs. Uses of visible light, lighting, so you can actually see what you're doing. Perception of color, this is necessary to see different colors. It's also necessary for photosynthesis. Without, we would die. So the light comes down from the sun, is absorbed by leaves on a plant, and is expelled as oxygen. So that allows us to breathe, as you remember from when we did it in biology. Ultraviolet light comes from the sun. Ultraviolet rays strike your skin. That allows them to make vitamin D, which makes you a healthier person. Different other uses for this. So where does it come from? Comes from the sun. It also is found in tanning beds. So it's artificially recreated in there. Uses. If you think about in the back of our lab in the school, there's that bin where we keep the goggles. In that bin where we keep the goggles, if I lock the door and turn on the light switch, that's actually ultraviolet rays that are being used to sterilize or clean any germs or bacteria off of those goggles so that people aren't transferring any illnesses that they may have between classes. So it's often used for sterilization. It's often used for solving crimes. So UV light is used to detect blood when it's combined with luminol. Tanning beds use UV light. Dangers of UV light, you may have heard that tanning beds are a little bit more dangerous, is that overexposure, either from tanning beds or the sun, or if you decided to open up that goggle cabinet, overexposure can cause sunburns and skin cancer. So it's a thing that you don't want to get too much of, which is why it's really important to wear sunscreen. X-rays. If you've broken a bone before or been to the dentist, you've likely received an X-ray. So uses, X-rays are produced in an X-ray tube, and they can be used to create images of teeth and bones. Dangers of X-rays. Overexposure can be dangerous, so you'll know if you've gone to the dentist that they'll often put a apron over top of you that's quite heavy. That's because that's there to protect you from getting overexposed. So if they're only looking to do an x-ray of your wrist because you broke your wrist, there's no reason why your whole arm needs to get exposed to x-rays. So x-rays in low doses are not dangerous, but overexposure to x-rays or unnecessary exposure to x-rays can be dangerous. Gamma rays. So gamma rays, they come from unstable nuclei, so they can be produced by blowing up atoms. So you might have heard of atomic bombs. Gamma rays are the highest in energy and they have the shortest wavelength, so they're really quite close together. A gamma ray, so I actually can show you. Pen. So they're really, really close together. Really, really close together. Not as much space in between them. So gamma rays are used for a lot of different things. Typically, a focused burst of gamma rays are used in radiation therapy to kill cancer cells. So they're quite dangerous because they can kill or destroy things. But when we're talking about cancer, that's something that you'd like to get rid of in your body. So very, very tiny kind of focused bits of it can help with curing cancer. Doctors will often ask patients who have cancer or other illnesses to swallow iodine. So gamma ray camera image of a thyroid gland injected with radioactive iodine. So iodine is placed in with a little bit of gamma ray in it. And what can happen is that the camera can detect more gamma rays in the areas that are infected and are problematic. So it's used to treat thyroid cancer. So when a patient swallows it, it's also going to the thyroid gland to kill those cancer cells and kind of make everything more apparent there. So just in case you're kind of looking for more information about today's lesson, I've collected a bunch of different resources. This one's particularly interested because, as I mentioned before, just because we can only see visible light doesn't mean that's the same for every other species. So, for example, dogs have different kind of things that they can see in their vision. Some reptiles, I shouldn't write with this, it looks bad. Bugs have different wavelengths that they can see, so you can take a peek at some of that if you're kind of curious. And there's a couple of different videos that talk about the electromagnetic spectrum if you're confused. For your assignment, I'm just going to pull it up. For your assignment, what I would like you to do is the electromagnetic spectrum has lots of other uses that scientists have taken advantage of. So I'd like you to look into some of them. So what you're going to do is you're going to create your very own electromagnetic spectrum diagram. The first kind of step here is going to be to draw out these waves. Make sure that as you're going along, you're getting smaller and smaller and smaller and smaller. So your task is you're going to create a diagram very similar to the one shown above. So this one has a few things that I'm asking for that are missing, so don't copy it exactly. But this is kind of an idea of what you're creating. So you're going to create an electromagnetic spectrum diagram similar to the one shown above that shows the size and source of waves for each of the 7 regions. So when I'm talking about regions, I'm talking about radio waves, infrared rays, microwaves, ultraviolet X-rays, gamma rays, etc. So all of those things on that spectrum. So it's a spectrum. So they're all kind of forms of light. First, I'd like you to fill in the chart on the next page. This is going to guide how you're going to format this assignment, and you're going to turn it in when you turn in this assignment. Excuse me. So you're going to fill in this chart below and use it as a guide for what to include on your electromagnetic visual diagrams. So I've given you an example of radio waves. You can add some more information. You should be able to add as much information as you like. But this amount of information is absolutely enough for this assignment. So radio waves, they're large. So one wavelength is around the size of a building. So we're talking about the distance between the top of one wave to the top of another wave. It's around the size of a building, so it's quite big. Examples of things that give off this type of radiation, we're talking about radios. You could talk about televisions. Is it dangerous? You can do a little bit of research on here. I've provided a little bit of information in the PowerPoint. And then any inventions that allow us to see this type of radiation. So for example, infrared goggles can show us heat radiation or infrared radiation. There are a type of technology that do show us radio waves. So radio telescopes can be used to actually read radio waves. And this allows us to see black holes in space. So this is kind of an idea. So you're going to fill in this information for all of the different types of electromagnetic radiation. I've given you a list of some resources you can use for some of these different things. So for example, if we take a good look at this one. So if you want more information about radio waves, talks about how they're made, where they come from, some other uses that you can take and use and incorporate in your assignment. So those some kind of sources. So for each of the things on your thing, you're going to first draw out the image of a wave. So I'm talking about this guy here. So you need to draw out the wave. Label all 7 regions of the electromagnetic spectrum. So I'm talking about radio waves. This one's missing its microwave label. Infrared, ultraviolet, X-ray, gamma rays, etc. Then for each of these regions, similarly to how it's been happening here, you're going to draw or find a picture of an object that's around the same size as that wavelength. So a building is the size of a radio wave. So that's what this person has done here, versus a gamma ray is around the size of an atom. So you're going to draw or find a picture of that object. So that's around the same size. I don't need you to tell me how many meters or how long. I just want you to give me kind of an example of how big it actually is, so you can visualize it. You're going to draw or find 3 illustrations or images of objects that give off, so they produce, like the sun produces infrared, or use that type of electromagnetic radiation in that region. So specifically, you need 3 pictures or examples of things that use that type of radiation. So 3 things that use radio waves, 3 things that use infrared pictures. And then list any dangers that these regions of the electromagnetic spectrum may cause. So we're talking about how UV light can cause skin cancer. This is an idea of how you can organize your project. Doesn't need to be this perfectly organized, and of course you're going to have pictures, but you're going to have the title of the region of the spectrum. So the first one on this side we're talking about is radio waves. How big are the waves? You can have your picture of a building here, and then 3 pictures of things that use or give off this type of radiation. So you could have a star, you could have a radio, any dangers. And then any devices that allow us to see us is a little bit of a bonus. Okay, so again, these are some resources that you can use, as well as the PowerPoint. I'm not expecting you to get any information that's not provided for you here. Yes, and that's your task. Okay, so good luck. Let me know if you have any questions, and I'm going to post an opportunity to have a little kind of meet and greet and chat for any extra help or questions that you guys might have about this assignment. Thanks so much. Goodbye.